concentration is a small number, and we're dividing it by a couple hundred. Now, if I want to find the rate for the other ones, I just go down here, and there's that emphasized little square down there. If I grab that and I drag down, it will automatically fill in the formulas for the other cells. Now we'll go up here to the iron concentration. This is the iron concentration initially in the reaction. This is where we use the dilution equation. So for this particular one, we're looking for M2. This is the same as M2 in the dilution equation. So this is equal to volume 1, let me put the equal sign in, equals the volume, whatever is in the cell next to it, times the original molarity of the iron solution. What's the original molarity of the iron solution? 0.05. The iron solution out of the bottle should be 0.05. Divided by, what's our total volume?
50 milliliters.
In each case, it's 50. Okay, so there is the iron concentration initially, 0.0025. It's the iron concentration in the 50 milliliters of solution once we've combined the two reactants. Natural log of iron equals, to start the formula, now we enter the function ln for the natural log. We are going to operate on whatever, we're going to carry out the natural log operation on something, and that something has to be in parentheses. So we're just going to take the negative log of this number for whatever's in the cell to our left. So equals natural log, I clicked on that cell, now I hit enter, and it gives me the value. The iodide concentration, this is the one that doesn't change. So what is the molarity of the iodide concentration that we took out of the bottle? It's equal to the original concentration times the volume that we took for each of these runs. What was the volume of iodide solution? 5. Divided by the total volume of 50 milliliters once we've combined the solutions. So the iodide concentration is the same. Remember, it's the concentration that we took out of the bottle, now diluted to 50 mils, once the volume of the total combined solution. So I hit enter there. There's our iodide solution. Now, the next column is the natural log of the rate. So this is just like we did for natural log of iron, equals ln. We're going to operate on whatever's in parentheses. I just go over here and click on the rate column. Close the paren. And that's it. Now I've got 4 columns. I've entered the formulas. I'm going to highlight those 4 cells. I'm going to grab the lower right corner just like I did before. I'm going to click and then drag these down, and it will autofill those numbers. And now I'm ready to find out the value of A. So now that I have these numbers, it is down here. I'm going to take this column, I'm going to hold down the control key and highlight this column because those are the 2 columns I want to plot. I want natural log of iron on X, I want natural log of rate on Y. So now that I have those points highlighted, I go over here to the Insert tab, up in the upper left. I go to Insert, and I want to insert a chart that is a scatter plot. So I'm going to click on it, and it gives me some options. I'm going to click on the scatter plot and it gives me an example of what it looks like. I haven't clicked on it yet, where we connect the dots with straight lines between them. So I click on this, and there it is. Any questions on this so far? So it's very systematic. If you've never used Excel, this can be a little bit challenging. If you've used Excel, this is how you just normally graph data. You click and drag over your X data, you click and drag over your Y data, they're both highlighted at the same time, and then you click on graph, whatever kind of graph you want. So scatter plots are nice because they will auto-adjust the space in between the data points. What I'm really looking for is the equation of the line, because it's the slope of this line that will give me the value of A. So I go over here to the line, I highlight it, I left click on it to get this. Now I'm going to right click, and when I right click, it gives me a menu. I want to go to add trend line, which is the second to the bottom menu option. So I hit add trend line, and it opens up this window on the right hand side. I go to this window, I can do all kinds of lovely formatting here. I go down to the bottom two commands, display equation on chart, and display R squared value. What it just did was it put those two items here in a box on the graph. So I'm going to click and drag that box over. And now I have the slope. Y is equal to 1.0032x minus 7.6077. The 1.0032, that is my slope. So I'm going to close this box of trend line. I'm going to click on and hold and move this graph off to the side. And I'm going to enter the value of A right here as 1.0032. 1.0032. Enter. A is an important number. The data should be a whole number. It should be close to an integer. Now these data were actually collected by one of our prep DAs. She ran the experiment yesterday and collected these numbers. We do the same thing down here. You can't do anything with K yet. You do the same thing for B. Now these numbers she did not collect. We made these up. And so we made them kind of idealized to fit. So these are rough times for what we thought could look like down here. We do exactly the same numbers down here, except notice that I replaces Fe. So up here, this is milliliters of Fe, this is milliliters of iodine. Up above, it's concentration of iron initial. This should be concentration of iodide initial. Natural log of iron, natural log of iodine. Okay. Now this column, so these columns are swapped. This is natural log of iodide. Up here, iodide initial, iron initial. So now we've got everything ready to go. The calculations are exactly the same for natural log of iodide, natural log of rate. If we do that plot, we get a slope of 1.9662 with these numbers. So you do exactly the same thing down here that we did above. All right, now, 1.9662, so those are the two slopes. Now we know the values of A and B. Any questions so far? Yes?
Is this spreadsheet going to be online?
No, you've got to build your own. You're given the headings. You're given the headings. So keep in mind where I started from. The data that you know already, this is what you measured, and these are the concentrations of iron that vary from time to time. All the rest of the information you've got in the lab. So you're going to calculate the rate from this, because I just told you, I just gave you the formula to put in here. You've got to enter these formulas on your own. Okay? There's no point in us just handing them to you. You know, work through these calculations. It's really not that hard. That's why we're going through this now. So now we know A, now we know B. I'm going to now enter the formula to calculate K. So what do we know? Let's come back to our rate law. We know rate is equal to K, this to the A, this to the B. So what the things that vary from run to run? This varies, and this varies. What are the things that stay the same from run to run? Well, for these 8 trials, K was the same because the temperature was the same. A and B. Now that we know A and B, those are flat fixed. In order to solve for the rate constant at this temperature, K, I just take this and divide both sides by this chunk. So we just move it under here, under the rate, and that's what we have. So I'm going to enter the formula for this in the spreadsheet now. Equals the rate, so I just click on this cell here. You know the difference between an absolute and a relative reference? Okay, so what I've been doing so far for all of these is a relative reference. So for example, for natural log of rate, I typed in equals ln and I clicked over here. Now when I clicked over here, it said, when I clicked over there, what that really told this cell was, I'm going to take the negative log of the cell that is 1, 2, 3, 4, 5 to the left of me. When we just enter the C3, row C, column C, row 3. An absolute reference is what I'm going to use for A and B. What that means is you put dollar signs around it. When you put the dollar signs on it, it says, I'm not looking for the cell 5 to the left of me. I'm looking for that exact number every time. That's what an absolute reference is. So C3 is the rate, and I'm going to divide that by this denominator that is the concentration of iron. Where's the concentration of iron? That is right here in F3. That is now raised to the A. Shift 6, the little caret sign. So to that power, I'm going to hit the value that's in the value of A. Now, this is the first time we're using an absolute reference, because if I were not to put the dollar signs in, and I close up the formula with this format, when I do the drag down, this is H7 is down here. The same spot here, it's going to look for a number here. For this cell, it's going to look for a number here. This, it's going to look for a number here. That's a relative reference. It floats. As you fill a formula down, it floats for other data here. For these numbers, I wanted to refer to these numbers that were changing from time to time. But for this particular number, that exact number and this exact number each time. So the way you do this on a PC is you just hit the F4 key. If you hit F4, it puts the dollar signs on it. Notice that it's $H, $7. On a Mac, I think it's like Alt-Shift F4 or something like that. There's 2 other commands that have to go with it to do it. Or what I end up doing on my Mac is I'll just type them in if it's that important. Okay, that is iron to the A, and I want to multiply that times iodide. And that's the reason I put this column here. I put this column here to put in the concentration of iodide, and now I want to raise that, shift 6, raise that to this power, which is H14. Make it an absolute reference, close the parenthesis, and that's it. That's the formula. It's simply solving K from the rate law. I hit enter. Now I go to the box, drag it down, and it fills in the rest of the K values. Notice that K is not exactly the same, but it's pretty close. This number is simply the average of the 4 above. So that's what we do. You can do K the exact same way down here. You can't do K until you know the values of A and B. so to do the average, okay, here's how you do it. I push equal, and then I type the word average, and then parentheses, and then you click and drag the cells that you want to average. Put them in parentheses. And then you hit enter, and then it'll do the average of those numbers. Okay. That is all we're going to do for now. For the rest of it, for doing the activation energy, we have a lot more to talk about in class. And we'll go through that calculation in class before you can actually do it. Okay, if you don't get there in class, ask your instructors to talk about the lab data. And then they should be willing to use that as an example for how to walk through those calculations. Now, is it complicated? If you've never used Excel, it can be complicated. How do you use commands? How do you do formulas? Now, if you need help, Science Help will help you through this too. Most of the people in Science Help have been through this calculation before. They can help you set up the spreadsheet, help you walk through it. This lab will not be due until next week. So before you leave lab today, I think it would be good for you, if you don't have Excel, that's fine. You could use one of the Bethel computers if you want to use it. I don't know if Sheets will do the same commands. But if you haven't used Excel, use one of the computers in the library. Use one of the computing labs, a computer in one of the labs. And so for example, this computer over here, there's one over here on the wall. You could use that. You could come down and use our laptops. So those are available to you. Come down here, pull a laptop out, log on, go ahead and use Excel. So we want you to develop that Excel skill. It's really, really important for processing data. Okay. All right, so if you can get through this, then you can get through this. Don't worry about K until you can get through this stuff. Work through the fundamentals first. And hopefully it won't be that bad. All right, so when you leave today, you just have your data together. If you want to start this, you can, but you don't have to.